All right, today, this is the first lesson of the unit. This one is called points, lines, and planes. And points, lines, and planes are actually undefined. That's important to know. That will be asked on tests and so on in this class. So you can describe them, but technically there's no geometric definition for a point, line, or plane. But points, lines, and planes are building blocks of everything else that we do. So points, lines, and planes are going to be undefined. Now, by definition of a point, it's a location that has no size. And so if we were to draw one of those, it would just be a dot on your paper or a dot on the board. That would be our picture of it. Now a label, we would give it just a capital letter. So this would identify that point as point A. Now a line is a series of points. If we did enough points in a row small enough together, they would actually create a line. And the one thing to keep in mind is that this line goes in two opposite directions without end, and the without end refers to the arrows. Now to identify a line, there's two ways. One way would be we would need 2 points. So if I labeled point A and point B on the line, I can identify it as line AB. Now, there's a different way to identify a line. We can also use lowercase letters. Sometimes we'll see examples where we'll have a lowercase italicized letter. In this case, that's going to be line M. So there's 2 different ways to identify a line depending on how the line is presented. All right, a plane is going to be a flat surface that has no thickness. In class, we'll often talk about a plane being like the board or the floor or the ceiling or one of the walls in the room. Right? It contains many lines and goes in all directions without end, and it contains all of its lines. All right, so it's really, really important for you guys to know that all 3 points, lines, and planes are undefined. All right, coplanar is the next term. Coplanar means points and lines in the same plane. This term co means the same plane. So considering that the board is a plane, if I were to draw this picture on the board, these are all coplanar lines. These points and lines are coplanar on the same board. If I had a point on the side wall, that would not be on the same plane as this particular board. Collinear means points that are on the same line then. So if we look at this example here for 3 collinear points, we see that A and C are 3 points on the same line. We also see that D, M, and B are on the same line. So AMC, DMB are the collinear points. Now non-collinear points means one of them is not on the same line. So in this case, here would be an example, would be A, B, and M. So we see A and B are in the same line, but M is not. So that would be one example of a non-collinear point. All right, we also talk about things like axioms and postulates, and to keep it simple, there is formal definitions and descriptions of this, but I just want you to think of it as a definition, just something that is going to help us use properties to solve. So do not get confused when you see the term postulate or axiom. So we talked about for postulates, if you have 2 points, there's exactly one line. So we can connect 2 points, WB, with only one line. We cannot draw 2 lines through those points. We would need a 3rd point to draw a 2nd line. The next postulate says if we have 2 lines that intersect, they intersect in only 1 point. Right? And the next definition says if 2 planes intersect, they intersect in exactly 1 line. So if you can see here, the board and the wedge of the chalkboard intersect, and they intersect in this line right here that they meet at. So that's what that is describing it. Now, one of the things you'll have to do is describe what planes in the line that's formed by the intersection. So if we look here, if we have plane ABC, which by the way, a plane can be identified using 3 points or 4 points, as long as the 3 or 4 points are non-collinear. So if we have plane ABC and we have plane DBA, we see that they both share the points BA. So if I had a plane kind of drawn that way, like the walls of a classroom, right? And if I have C, A and B, and I have D over here, they would both have the line AB shared. So ABC is this plane, ABD is this plane. What do they have in common is A and B. So that's one way to do that. There's another way as well, where we we can define them based on front, back, left, and right. Okay, so if I were to draw a box, for example, okay, and I had this plane here, A, B, C, D, and then on the bottom, E, F, G, and then in the back corner would be H. Okay, so hopefully you can see that there, right? If I want the intersection of plane DFCG, okay, so that's going to be the right plane, and I want the intersection of A, B, C, and D, that's going to be the top. So the intersection is going to occur in the top right line. So if we look here, the top right line is going to be CD. But if we look here, we also see that the common points they have in common are also CD. So this is the preferred way to find the intersection of two planes, is by identifying top, left, front, back, and so on, based on the picture or the diagram provided. Okay. All right, again, just a few seconds ago I talked about if you have three non-collinear points, then a plane exists, and that's how we describe a plane. I mean, yeah, it's 3 points not on the same line. Again, I'll go back to this example here where we have a plane with these 3 points here, A, B, and C, and then we have this plane here where there's an extra point, D. So if I said plane ABD, it's pretty clear that we're talking about this plane, or if I said plane ABC, we're talking about this. But if I had a third point here as E, and I described it as AEB, what plane is AEB on? We don't know. So we need that point off of that line to determine what plane it actually is part of.